Okay, good morning, everyone. Yes, good morning, everyone. So around 26 of you have joined. Okay, so as you can see, the topic that we are going to start today is heat transfer. Okay, so the last class we studied about, tell me, we studied about calorimetry, thermal expansion, right? And some terms related to heat. What is the zeroth law of thermodynamics? What is calorimetry? Okay, how? Yes, very good, Samya. Okay, so I hope all of you remember all those concepts. Tell me. I hope all of you remember all those concepts. Yes, very good. Okay, so before starting today's class, let's have a small recall test based on what we have studied in last class. Okay, let's have a small recall test. Okay, so tell me, this is, yeah, so these are the very easy small recall test, right? So the Fahrenheit and Celsius scale agree at a reading of, right? Or is same at a reading of? Yes, very good, Avas. It's easy. We have discussed this. Tell me. Very good, Samya. Very good, Anisha. Correct. Okay, second one. Boyle's law, right? Boyle's law is used only for, tell me. Very good. Very good, Nishita, Samya. Okay. Third, the graph of Charles' law is called an, tell me. The graph of Charles' law is called an, these are something that we have studied in chemistry. Okay. Right. Okay, Shuhas, Nishita. Okay, let's see what's the answer. Fourth one. Fourth one. The relationship between coefficient of expansion, area expansion, right, and coefficient of linear expansion is. Yes, very good. Very good, everyone. Yes, Vivek. Okay. Fifth one. When a body is heated, then maximum rise will be in its, tell me, maximum rise will be in its length, surface area, volume, or density. Think about it. Think about it. Think about the concept that we have studied. Right? Yes. Okay. Let's see the answers. So the first is minus 40, which is correct for most of you or all of you. Second is ideal gas, correct for all of you. Third is called as isobar. Okay. Third is called as isobar. Okay. Fourth is your, tell me, B. Fifth is volume. Fifth is volume. Okay. Got it? Because it is V is equal to V naught 1 plus 3 alpha delta T, na? Right? Got it? Okay. So when you talk about this topic, we already talked about what is specific heat capacity. So we studied this topic. Yes or no? Tell me. I hope all of you went through the videos, right? We already completed this topic. What is specific heat capacity? What is heat capacity? We studied in the last class. Okay. So let's have a small concept as based on that. The specific heat capacity of the substance depend on, okay, first is nature of the substance, second is mass of the substance. Tell me, what is the answer of this? Specific heat capacity, guys. Specific heat capacity. Yes, very good. Samya, Suhas, very good. Guys, think about it. It is specific heat capacity. Specific heat capacity, not the heat capacity, right? Yes, very good, Akshaya. Very good. Right? So the answer is one only. Because when you talk about specific heat capacity, it is by m delta T, right? Which means it is the coefficient when unit mass, okay, unit mass is taken. So it is not, it will not depend on mass. Okay. Then we studied calorimetry. We completed this topic also. Okay. So let's have one concept as based on this. Think about it, guys. Think about it. So the question is, the person is more, yes, severely burnt when the ash is brought in contact with skin, right? Easy. Yes, very good. Very good, Ria. Very good, Oves. Yes, concept of class 8, 9. Right? Easy. Yes. The answer is A. Quite easy. Now, triple point of water. So this is also concept of class 8, 9. Okay. So what do you mean by triple point of water? Tell me. What do you mean by triple point of water? Tell me. Anyone? Yes. Yes. Very good. So this is a point at which, right, any liquid exists in all the three forms. Okay, right? So this is just a theory, Okay. So anyways, today we are going to start a new topic, which is your heat transfer. Okay, which is your heat transfer. Now, when you talk about this topic, heat transfer, okay, think about it, right? Think about it. Okay. So let's talk about something that we have already studied in junior classes. Okay, so when you talk about heat transfer, what is the meaning of heat transfer? Tell me, what is the meaning of heat transfer? Tell me, what do you mean by heat transfer? If someone is saying, okay, heat is transferred from one body to another body, what is the meaning of that? Tell me. Yes, just think logically, right? You can just think what is the meaning of heat transfer, because we have already discussed. Okay, so I can say that, okay, when heat energy, okay, is, tell me, is, yes, when heat energy, right, flows from one, yes, one object to other object, okay, or one atom to other atom, because of change in temperature. Okay, because change in temperature, then that process called as heat transfer. Yes or no? Tell me, yes or no? Yes, so that's correct. Okay, so my question is, okay, I can say, okay, if I'm having two object, okay, one at higher temperature and one at lower temperature. Okay, so T1 is higher and T2 is lower. So I can say that the energy will be transmitted from T1 to T2. Okay, and that is the basic sense. That is what heat transfer is. Now my question is, okay, in how many ways it is possible? Tell me. This is something that we have studied in class 7. I hope all of you remember, right? So in how many ways it is possible? In how many ways it is possible? Tell me. Think about it. No, I'm talking about the ways of heat transfer. Okay, I'm not talking about the type of energy. I'm talking about way of heat transfer. So it can be done. It can be done in three ways, right? So heat transfer can be done in three ways, right? Out of three types. I hope all of you remember these three types that we have studied in junior classes. Yes or no? Right? Heat transfer. I'm talking about just heat transfer. First is called as conduction. Conduction. Okay, now my point is, what is conduction? Tell me, what is conduction? Think about it. What is conduction? Not induction. Induction, no induction, OS, right? Conduction, convection, and radiation only. We will study these three. Okay, yes. So when you talk about temperature, okay, when you talk about temperature, I can say that, okay, temperature is nothing but the property of a substance which possesses a kinetic energy, right? Yes or no? So I can say that, okay, temperature of any substance is associated with its kinetic energy. Makes sense? Tell me, makes sense, right? So this is what we have already studied in chemistry part. Now think about it. Suppose I'm having a container. Suppose I'm having a container. Let's have a container. Right? Let's have a container like this. Okay, this is my container. Okay, now, or this is a rod. You can imagine that this is a rod, and this, obviously, when you talk about any substance, it is made up of small atoms and molecules, right? So we have different atoms and molecules. Okay. Now my question is, okay, so what is the meaning of conduction? So what I want to do is, okay, so this is one substance which is in equilibrium. Yes, right? So let's keep this point A, keep this point A, this point B, keep this point A, okay, on flame, right? Or give it temperature T1 because of flame, some flame kind of thing, right? Some flame, okay, right? Heat it up. So the temperature of this will rise, yes or no? The temperature at this end will rise. So I can say that, okay, if the temperature is rising, which means the molecule which is nearer to this point will start vibrating. Yes or no? They will start vibrating because they will gain more kinetic energy. Makes sense? Tell me, makes sense? Right? Yes, but they will not leave their position. They will not leave their position. They'll just vibrate vigorously. They'll have more kinetic energy, but they will not leave the position, right? Now what happens? Suppose if it is vibrating, right, it will disturb the neighboring atoms, right? Or it will impart the energy to the neighboring atoms. Now this will also vibrate, right? Now again, this will also vibrate and so on. So they'll be passing on the energy from one atom to another atom directly. Yes or no? Tell me, yes or no? Right? And this process of transfer of heat is called as conduction. Okay, this process is called as conduction. Makes sense? Tell me, makes sense? Anyone have any issue? Tell me, anyone have any issue in this? I hope all of you are like clear about what is conduction. Okay, so definition wise you can write. Now when you talk about conduction, okay, so I want to know the heat transfer, rate of heat transfer. I want to know the rate of heat transfer, which is dq by dt. Okay, dq by dt, right, which is the rate of heat transfer. Now let's try to think, because obviously it is the fundamental process. Okay, so let's try to think that on what factor this rate of heat transfer will depend. Now think about it. Suppose we have 100 degrees centigrade over here, and here we have 20 degrees centigrade in case 1. And in case 2, we have 150 degrees centigrade, and here we have 10 degrees centigrade. Now what do you think? In which case the rate of heat transfer would be more? Tell me. In which case the rate of heat transfer would be more? Intuitively, tell me, intuitively. Think about it. Intuitively. Second case makes sense, na? Right, Krishna? Yes? Okay, very good. Now, but suppose instead of 10, I gave you like 40 degrees centigrade. Suppose instead of 10, I gave you 40 degrees centigrade, right? Then still 2, but instead of 40, if I say that the temperature at point B is suppose 80 degrees centigrade, then tell me, then which case? Case 1, right? So from this I can observe, okay, the rate of heat transfer will not depend on individual temperatures, right? It will depend on the difference between 2 points. Yes or no? Yes or no? Right? So I can say that, okay, this rate of change of, yes, this rate of heat transfer is directly to change in temperature, which is delta theta. I'll just write delta theta because T will be used for time also, right? Or you can write as dt, right? Doesn't matter. Okay, makes sense. Tell me, makes sense, right? Okay, now second thing, suppose if you are heating this, surface, this point A, then all the molecules of A, which is near to A, will be having high energy, yes or no? Tell me, yes or no? Right? Yes. So if suppose if the area of cross section is more, what do you think? More energy can be transferred, yes or no? Yes or no? Logical, makes sense, na? Logical, right? So yes, I can say that, okay, it is directly proportional to cross sectional area also. It is directly proportional to cross sectional area also. Okay, now let's talk about other factor. Now think about it, okay, suppose okay, now suppose the length of this rod is 10 meter in one case, and in other case suppose this is 20 meter, 20 meter. Right, see, whenever I'm talking about this, right, I'm keeping all the other parameters constant. Okay, I'm keeping all the other parameters constant. Got it? Okay, so what do you think? What do you think? Just think about it now, right? In which case, right, you'll be able to transfer more energy from one end to other end. Case one or case two? Case one or case two? First case, now makes sense, right? Case one, now. Case one, because see, again, think about it now, think about it, right? Because when you talk about energy, it is vibration. So obviously the vibration, think about it, vibration, right? It's not that it is a transfer from one point to the point without any loss. Obviously there'll be loss, right? There'll be loss of energy, yes or no? So the more distance it will cover, the more loss will be, yes or no? Tell me, yes or no? That is the concept of resistance, right? That is the concept of resistance. I hope all of you can relate this with current electricity. Yes or no? I hope all of you can relate with this current electricity. Got it? Right? So I can say, okay, it is inversely proportional to length. Inversely proportional to length. Got it, everyone? Tell me, got it? Anyone have any issue in this? Anyone have any issue in this? Tell me, no? Easy? Easy? Right? Okay. So I hope this concept is clear for most of you. Yes, very good, Suhas. So I'll just club all these, right? Let's try to club all this. So I can say, okay, d theta by dt is equal to. Okay. Now, if I club all this, I have to give a constant k. Then we have delta theta, right? Then we have a divided by L. Now think about it. Think about it. I want this to be a positive quantity. I want this. Got it? Yes or no? But what about delta theta? Delta theta will be positive or negative? Tell me. Delta theta will be positive or negative? Because heat is always transferred from higher temperature to lower temperature. So delta theta is always negative. Yes or no? Tell me. Yes or no? Can you transfer heat from lower temperature to higher temperature? Think about it. No, right? So in order to make it positive, I have to multiply by negative sign over here. Right? So this is the expression minus K A delta theta by L, okay, for rate of heat transfer, or I can just write it as IT, right? IT. What is IT? It is also called as heat current. Yes or no? I hope all of you remember the concept, right? It is also called as heat current. Got it? Tell me, got it? Anyone have any issues? Okay, very good. Now, related, right? The, this is quite easy. Why? Because if you can relate it with current. So what is Ohm's law? Tell me, what was Ohm's law? Let's talk about Ohm's law because this is something that we all have studied in class 10th. So Ohm's law say that, okay, I is equal to V by R. Yes or no? Yes or no? Tell me. Anyone have any issue in this? Anyone have any issue? I hope all of you remember I is equal to V by R, where V was potential difference. V was the potential difference because of which the current will flow from one point to other point, right? Now, relate this. And R, what was R? R was rho, tell me, A by L. Sorry, rho L by A. Rho L by A. Yes or no? R was rho L by A. Makes sense, right? So if you see this, I'll get a expression like this. A into V by rho L. Yes or no? Tell me, yes or no? Think about it. I is equal to. Anyone have any issues in this? Tell me, anyone have any issue in this? Till this point? No, this is what we have already studied, right? Now let's talk about this. So I can say that dq by dt, okay, right, which is heat current I T. T means thermal. IT means thermal. This is just notation that I'll be using. Okay, is equal to delta theta divided by. Okay, think about it. Divided by what? L. Okay, divided by L by Ka. Okay, negative sign. Yes or no? Tell me. Yes or no? Anyone have any issue in this? Anyone have any issue in this? Right? So I'll just ignore the negative sign, okay, because I'm just talking about the value. So it is delta theta divided by RT, right? Where RT is equal to L by Ka, where RT is R thermal resistance. Now, anyone have any issue in this? Tell me. Anyone have any issue in this? Can you take the analogous of these two cases? Yes or no? Raise your hand if you understood all this concept. Just raise your hand. Right? Okay, very good. Now, if I want to write, I can say, okay, IT is equal to, right, T. So delta T was T minus T initial. But if you include I, so it will be T higher temperature, minus T lower temperature by RT. Anyone have any issue on this? Tell me, anyone have any issue in this? Anyone have any issue? No? Make sense? Tell me, make sense? Easy? Everyone got this concept? Sumaya, Sai Smriti, Anjali, Chulika, Tulip, Anamika. Anamika, you are not connected to voice. Akshaya, Koshi, Mansi. Okay, very good. Right, very good. So let's try solving one easy problem. Okay, let's try solving one easy problem that I'll give you. Okay, so try solving this problem. Okay, suppose you have an aluminium cube. Okay, with A is equal to edge. A means edge is equal to 2 meter, right? Okay, got it. And so when you talk about the edge, right, one edge is maintained at temperature T1, which is equal to 100 degrees centigrade. Okay, and the other edge, right, T2 is maintained at temperature T2, which is 0 degrees centigrade. Got it? Tell me, got it? Right? Okay. So my question is, what is the amount of heat which is flown through this in 5 seconds? In 5 seconds, right? If thermal conductivity, K is called as thermal conductivity, by the way, right? Yes or no? Because it is 1 by K, na? So K is thermal conductivity. K is thermal conductivity. Sorry, I just thought that you guys might know already. Okay, so if thermal conductivity, which is K, is given by 209, okay, watt per meter degree centigrade. Okay, okay, think about it. Think about it. Easy formula putting getting. Easy formula putting getting. Try solving this and let me know. Formula putting getting, guys. Formula putting getting. Formula is Q by T is equal to TH minus TL divided by RT, right? Where RT is equal to L by K. Okay. Now, when you talk about A, right? This A is the edge length, which is L. So I can say that L is equal to 2 meter given. When you talk about area of cross section, since it is cube, area will be 4 meters square. K is given. So what is RT? Calculate RT first. So RT is equal to 2 divided by 209 into 4. Okay. So according to approximation, you can make it as 210, doesn't matter. Okay. So Q is equal to, now this is TH, which is 100, minus 0, it is 100, into temperature is 5. Sorry, time is 5 seconds, so 5, thereby RT, which is this, 2 into 200. Now, according to your approximation, you can just make it as 210 into 4 for easier calculation. Or you can just keep it as 209, doesn't matter. Okay, 2 times. You can keep it as 209, but 210 will give you easier calculation. Okay, so 2 into 5, 10, right? So we will have 3 zeros, 4 zeros. So it will be, or you can keep 209 also. It will be easy only. If you keep 209, right, still it will be having 3 zeros. Right? Joule. Anyone have any issues? Tell me. Anyone have any issues? Easy. So basically it is 209 kilojoule. So this is a formula putting getting? Yes or no? Yes or no? This is a level 1 problem. Okay, this is a level 1 problem in which you have to solve, okay, these kind of problems using formula putting getting. Okay? Yes. Okay. Now, second concept. So I hope first concept is clear. Tell me, this is concept 1. So concept 1 is clear. Raise your hand, everyone. Okay, right? Okay. So as I told you, I can use the concept of electricity that we have studied in class 10 in this. Okay, but we'll be expanding that concept. Now, there are some laws which we have to study. Okay, both in current and heat. It is called as Kirchhoff's, right? Actually, it's current law. Okay, we will be using this in both this chapter as well as in electric current, right? Current law, or basically it is Kirchhoff junction law. Junction, current or junction law. Okay, current law or junction law. So now think about it, right? Forget about this term. Just think about it. Suppose, I hope all of you have this water pipe at your home. Okay, suppose I can say yes or no. So this is first water pipe. Okay, right? Then we have this, yeah, we have this second water pipe. Okay, suppose we have this. Wait everyone. I cannot. Okay, sorry. Yeah. So suppose we have this second, okay, and then we have this third water pipe. Okay, right? And this is a junction. This is a junction. This is a junction. Makes sense, right? Think about it. Now, when you talk about these 3 water pipes, so obviously the thickness is different, right? The pipe length, pipe thickness will be different. Yes, I have taught in foundation of S. Okay, right? I've taught this in foundation. So you might, yes, so you might remember from that. Okay, now think about it. Think about it. So I'm talking about this junction. I can say that, okay, at this junction, doesn't matter what we have. Okay, so think about it. Suppose we have 10 liter water, 10 liter per second coming from this pipe. Okay, and 20 liter per second coming from this pipe. Okay, this is coming from this pipe and this is coming from this pipe. Okay, what do you think? from this pipe, how much water should be coming out? Tell me. How much water should be coming out? Easy, very easy concept. See, again, physics is actually that so much easy if you understand, right? Exactly, right? Yes or no? 30 liters per second, yes or no? Right? It's not that this junction will drink up water, right? Okay, no one is at the junction to drink the water, right? Yes or no? Yes or no? So can I say that, okay, whatever the amount is coming inside the junction should go outside, right? Or I can say that net sum of all the, yes, net sum of all the water will be zero. Yes or no? Yes or no? Right? Now this is in terms of water because it is more intuitive. Now think about in terms of current or heat. I'm talking about, see, I'll use the term current because it is your heat current in this chapter. So whenever I'm talking about current, you assume it to be heat current. Okay? Got it? Right, everyone? Whenever I say current, I'll be using term I, you assume it to be heat current. So can I say that, suppose this is I1, this is I2, and this is I3. This is I3. So can I say that, okay, I1, wait, something happened. Okay, yeah. So I can say that I1, so yeah, I was saying that, okay, so I can say that I1 plus I2 plus I3 should be equal to 0. Yes or no? Tell me. Yes or no? Right? I1 plus I2 plus I3 should be equal to 0. Make sense? Tell me, make sense? Anyone have any issue? Tell me, anyone have any issue? Right? So when you talk about this Kirchhoff junction law, I can say that, okay, net sum of all the currents at the junction should be 0. Net current at the junction should be 0. That is your Kirchhoff's junction law. Easy? Easy to understand? Yes or no? Tell me. Easy to understand? Yes? Now, think about it. Think about it. Suppose this is at temperature T1. This is at temperature T2. This is at temperature T3. Okay, right? I'll just grab this. Think about it. Okay. So, what do you think? What is I1? And this is obviously at temperature T. Yes or no? This will be at temperature T because it is your common temperature. Na? This is your common temperature. So, what is I1? Suppose tell me if I talk about I1. What is I1? I1 is, now first thing is either you decide the direction, right, or you just assume it to be in one direction. Okay, so I'm not assigning any direction for now. I'm not assigning any direction. Okay, I'm not assigning any direction. So I can say, okay, I1, right? Let us assume that I1 is T1 minus T by R1. I2, I2, suppose we have T1 minus T by R2 and I3 as T3 minus T by R3. Okay, why I'm doing this? Because I've taken all the current in one direction. Okay, so that I don't have to think. Okay, I don't have to think, right? So I can say I1 plus I2 plus I3 is 0. I1 plus I2 plus I3 is equal to 0. Yes or no? Tell me yes or no. Anyone have any doubt? Anyone have any doubt in this? Yes or no? Tell me. Got it? Everyone is getting this concept? Yes? Now, can you find T? Suppose R1, R2, R3 is given, T1, T2, T3 is given. Can you find T? Find T. Find T, junction temperature T. Right? Everyone, try to find this. Okay, find junction temperature T. Everyone do that. Okay, so let's see. Let's try to see. Okay, so I1, write down I1. I1 is T1 minus T by R1 plus I2 is T2 minus T by R2 plus T3 minus T by R3 is equal to 0. Easy, right? Easy. Now, when you talk about this, just separate it. T1 by R1 plus T2 by R2 plus T3 by R3 minus bracket T by R1 plus T by R2 plus T by R3 is equal to 0. As simple as that. In 3 steps you can solve, right? So take this to this side, take T common. So I'll get this. T is equal to summation of Ti by Ri, which is T1 R1, T2 R2, T3 R3 divided by. Now we will get what? 1 by R1 plus 1 by R2 plus 1 by R3. So it is summation of 1 by Ri. Yes or no? Or it is T1 by R1 plus T2 by R2 plus T3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Now tell me, this is clear to everyone? Tell me, clear to everyone? Yes, anyone have any issue in this? Tell me, anyone have any issue in this? Tell me. Krishna, got it? Vivek, Ramya, Tulip, Sanya, Sneha, everyone is getting this? Sumaya, Ria and Anamika, you both are together? Ria, Anamika, तुम दोनों साथ में हो क्या?
No, sir.
Okay, so Anamika is having some internet issues, I guess. Okay, no, Anamika is here. Okay, okay. So easy. You can solve one problem based on this. I hope all of you are finding it easy now, right? Think about it. Okay, very good. Now let's try to solve one problem. Let's try to solve one problem based on this. Okay. Now suppose I'm having the same concept. Okay, same concept. So we have this rod 1. Okay. Rod 2 and rod 3. Okay, rod 3. Now this is aluminium, this is copper, and this is steel. Okay, steel. So let it be at 12 degrees centigrade. This is at 12 degrees centigrade. This is at 4 degrees centigrade, and this is at 50 degrees centigrade. Okay, got it, right? And K of copper is given as 400 watt per meter Kelvin, right? Watt per meter Kelvin, right? K of steel is given as, suppose, 50 watt per meter Kelvin, right? And K of aluminium is given as 200 watt per meter Kelvin. Okay, got it. That's it. That's all you have to give in, right? Okay, and nothing else is given. Nothing else is given. Okay, find the junction temperature T. Find the junction temperature T. Okay. K aluminium is 200, right? Length is given as 1 meter each. Length of all three is 1 meter. Okay, and area is also 1. Area is 1 centimeter square. Okay, right? Tell me. Now find this T. Find this junction temperature. Find junction temperature. Easy? Tell me. Try to find. Okay, let's see how to solve this. So when you talk about the first method, it's not the method, it's actually the way to solve. Okay, so just use the formula. T is equal to summation of T1 by R1 or Ti by Ri divided by summation of 1 by Ri. Okay, now if you imagine what is Ti by Ri, which is T1 by, now think about it, area is same and length is same. So we know that R is equal to L by Ka. Ka. Okay. So T1 by L into K1A because it is same plus T2 by L into K1 into A plus sorry K2 plus T3 by L into K3 by A divided by, right, 1 by Ri. Now 1 by Ri means K1 A by L plus K2 A by L plus K3 A by L, right? Okay. Now if you can see that since A and L is same for all the three, you can take A by L common and cut it. Yes or no? Right? A by L common, A by L common. Right? Then you are left with T1 K1 plus T2 K2 plus T3 K3 divided by K1 plus K2 plus K3. Yes or no? Tell me yes or no. Tell me yes or no. That's why I said even though area and length will not be given, you can solve it. Okay, right? We can solve it. So this will be cancelled. Now put the value. What is T1? Tell me what is T1? So let us assume that T1 is for aluminium, which is 12. 12 into K1 is for again aluminium, which is 200. 200 plus T2 suppose for steel, which is 50 into K for steel, which is 50. Right, both 50 plus T3 is for copper, 4 into, and for copper it is 400 divided by K1 plus K2 plus K3, which is 200 plus 50 plus 400. Got it? Tell me, got it? Anyone have any issue in this? Anyone have any issue till this point? So just calculate it. Okay, calculate it. Now if you see, it is quite easy because 2400 plus 2500 plus 1600 divided by 650. So if you add all the three, we will get what? 6500 divided by 6500 divided by 650. 10 degrees centigrade. Yes or no? Yes or no? Tell me. Yes or no? Anyone have any issue in this? Anyone have any issue in this? This is method 1 to solve. This is method 1 to solve. Okay, right? Now what is method 2? Again, method 2 is if find R1, R2, R3 first. So R1 is L by K1A, which is 1 by, again, because everything is 1, 1, doesn't matter, it is same. 1 by, tell me, aluminium, right? So 1 by 200. R2 is equal to 1 by 50. R3 1 by 400, right? Then put it in the equation. Okay, put it in the equation and then solve it. Abhiram, you can calculate this in degree centigrade only, right? You need not to find in Kelvin because we are talking about temperature difference. Okay, so difference, when we talk about difference will be same in both degree centigrade and Kelvin. Okay, right? So I would request, especially in conduction, okay, in this, do not convert in Kelvin because your numerical values will be more. Okay, your numerical values will be difficult. Okay, right? So now you can use T1 minus T by R1 plus T2 minus T by R2 plus T3 minus T by R3. Okay, is equal to 0. Now put the value, get the answer. Okay, right? Yeah, sorry. Yeah, so it is 10 to the power 4. My bad, 10 to the power 4. 10 to the power 4. 10 to the power 4. Okay, got it, right? So anyways, you will get the same concept, same ideas. Okay, got it? Tell me, got it? I hope everyone understood this junction law. Yes or no? Tell me. Everyone got this junction law? Clear? Okay, very good, Pradyumna. Very good, Abhiram. Now, next, when you talk about the concept, so we studied, okay, in class 10th, we studied something called series and parallel. Yes or no? Series and parallel, right? Can I apply the same concept here? My question would be, can I apply same concept over here? Yes or no? Tell me, yes or no? Series parallel concept? Yes, 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 very good. Yes, I can apply the same concept. Okay, series parallel. Now think about it. Okay, when you talk about anything is series, okay, before talking about series and parallel, okay, because I was just wanted to know that how many of you, right, actually understood the concept of heat current, because you can take it as same way as your electric current. Okay, now the second law after Kirchhoff's current law, we have second thing called as Kirchhoff's, now this is called as potential law or voltage law. Okay, so I'll be using this. Now, this is your second. So actually we have to study this in electric current, but I'll be teaching you this here because it is easier to study. Now think about it. I'll be using resistance only, right? Consider resistance as thermal resistance. Okay. Now this is a potential source. So I just replace potential source with, tell me, heat source. Okay, got it. So why I'm using this convention? Because it is easier to use. Okay, right? So just try to understand this. So this is the source of heat. This is the source of heat. Okay, these two are source of heat, right? Got it. So the source of heat, I'll just say that it is delta T1 and it will provide delta T2. Okay, like that. Temperature here is TA, temperature here is TB, temperature here is TC, or I'll just use in terms of current only, right? You can just take the logas in temperature and heat current. Okay, so I'll just take in logas of this current only. So suppose this is your voltage VA, this is voltage VB, this is R1, this is R2, this is R3, this is R4. Okay, this point is VA, this point is VB, this point is VC. Okay, VA I've already used over here, na? So I'll just write as VQ and VP. Okay, this is VD, VE, VF. Okay, right, at each point. Now let's think about it. Think about it, right? Now, if we talk about voltages, think about it. What is the voltage between point A and B? Tell me, what is the voltage between point A and B? Everyone, think about it. What's the voltage between point A and B? VA minus VB? Yes or no? Right? B to C is VB minus VC plus C to D is VC minus VD plus D to E is VD minus VE plus E to F is VE minus VF plus F to A is VF minus VA is equal to, tell me what will be? It will be equal to what? Tell me, everyone, think about it. It will be equal to what? Tell me, it will be equal to what? Think about now. VB cancel, VC cancel, VD cancel, VV cancel, VF cancel, VA cancel. So everything will be zero. Yes or no? As simple as that. Yes or no? Right? So can I say that? Can I say that? Okay, in a loop, net change in potential is zero. Yes or no? Tell me yes or no. Okay, so we will be using this concept more in electric current, not in heat, but I just want to tell you this. We can take the concept, we can use this concept. Okay, now the next concept is series and parallel combination. Series and parallel. Okay, now first we talk about series. Let's talk about series combination. Series combination. Okay, now what do you mean by series combination? Tell me, what do you mean by series combination? Think about it. What we have studied in series combination? When resistance are to be set in series. Tell me. Tell me everyone. Yes, when the current through them is equal, right? Constant current flows through it. Constant current, not constant basically, same current flows through everything. Yes or no? Right? Same current. Same current flows through all the resistance. Yes or no? Tell me yes or no. Right? So in terms of resistance, I say like this. Okay, if we have a something like this, if we have something like this, right? Between same potential, between point A and point B, then I can say that, okay, this R1, R2, R3 is in series. Yes or no? Tell me yes or no. Right? Now think about it. What can I say? What can I say about this case in heat current? So let's talk about this. Let's talk about this. Suppose I'm having a block like this. Okay? And second block like this. Okay? And third block like this. Third block like this. Okay, and all the three blocks is between two reservoirs. Between two reservoirs. Okay, right? This is a temperature TA and this is a temperature TB. Now, can I say that? Can I say that? So for this, it is K1, K2, K3, A1, L1, A2, L2, A3, L3, right? So can I say that these three rods are in series? Yes or no? Tell me. Yes or no? Can I say something like that? Tell me. Can I say something like that? Yes, very good. Very good, everyone. Now think about what kind of question can be asked. Okay, so I can say that, okay, temperature at this junction should be T1. Let's suppose temperature at this junction is T1. Temperature at this junction is T2. Okay, so what can be asked? You can ask, right, how to find T1 and T2. The question can be asked is question number one. Question number one. Find I thermal, right? Second question. Find T1. Third question, find T2. Fourth question, find delta T, right? Which is T2 minus T1. Got it? So these are the questions that can be asked. Yes or no? Tell me yes or no. Think about it. Yes or no? Yes. Now how to solve it? How to solve it? Okay. So I said that, okay, sir, we just have studied Kirchhoff's voltage law. Yes or no? Kirchhoff's voltage law, right? Right? So I can use Kirchhoff's voltage law over here. Yes or no? Tell me. Yes or no? So what I can say, okay, we know that now that instead of potential difference, we have change in temperature. We have change in temperature. Okay, so I can say like this. I can say like this. Okay, TA minus T1, right? TA minus T1 is potential difference between this point plus T1 minus T2 is potential difference between these 2 points plus T2 minus TB, right, is potential difference between these 3 points. Got it? Tell me. Got it? And this is equal to TA minus TB. This is equal to TA minus TB. Makes sense? Tell me. Makes sense? Yes or no? Anyone have any issue on this? Anyone have any issue on this? Think about it. Anyone have any issue on this? First step clear to everyone? Yes, raise your hand. Yes, very good. And can I say that, okay, let's suppose since these three, this is your series combination. So current is IT, current is same as IT, current is IT only. Okay, so I can say that, okay, this change in temperature is basically IT by R1. Yes or no? Tell me. Yes or no? Sorry, IT into R1, my bad. IT into R1. Into R1. Plus this is IT into R2. Plus this is IT into R3. Right? Right, everyone? Tell me, right? IT into R3. And this is equal to TA minus TB. So can I say that? Can I say that? Okay, from here I can say IT is equal to what? TA minus TB divided by R1 plus R2 plus R3. Yes or no? Yes or no? Right? So if you can recall your concept, it is what? It is what? TA minus TB by R equivalent. R equivalent. Yes or no? Tell me. Yes or no? Can I say like something like this? Tell me. Can I say something like this? So don't you think, okay, this is same as what we have studied in maths. Sorry, what we have studied in electric current, my bad. Okay. So R equivalent is equal to R1 plus R2 plus R3. Yes or no? Tell me. Yes or no? Right? Anyone have any issue in this? Tell me. Anyone have any issue in this? Got it? Tell me, got it? Now, we know that if we want to find T1, so we know that TA minus T1 is what? It is IT into R1. Okay, so can I say, okay, T1 is equal to what? T1 is equal to TA minus IT into R1. Yes or no? Yes or no? Got it? Right? So you can find your I as well as T. Anyone have any issue in this concept? Tell me. Anyone have any issue in this concept? Same as electric current. Whatever we did in electric current, we'll do the same thing over here. Okay? Yes? Clear? Samya? Samarth? Sanya? Srihari? Sumaya? Tulip? Riya? Priyanka? Pritam? Pritam, you joined late. Vivek is not here. Vivek left. Okay. Okay, everyone, right? So let's try one problem. Okay, can you try one problem? Tell me, can you try one problem? Yes? Okay, let's try one problem. Okay, so I'll just give you the, yes, I'll just give you the easier version. Okay, so question is something like this. Suppose I'm having, okay, what happened? Wait. So I'm having 4 different rods. Okay, just imagine that we have 4 different rods, right? We have 4 different rods. They have 4 different rods. Okay, right? And temperature at this point is 25 degrees centigrade. 25 degrees centigrade. Okay, temperature at this point is 20 degrees centigrade. Got it? And temperature at this point is minus 20 degrees centigrade. Got it? Tell me, got it? Now, the resistance of this and this are both equal, R and R. Okay, this is equal. Now here we have current IT. IT will be same. Okay, got it? Tell me. Now, this is L1. L1. L1 is given as, suppose L1 is something, right? The value is not given, but it is given that L2 is equal to 5L1. L2 is equal to 5L1. Okay, got it? Right? L2 is equal to 5L1. And this are both of length L. Okay, got it? Tell me. Now, this is L1. This is L. L, same length, same radius. Okay, now let's see. This is easy. Why this is easy? We know that across all the 4 resistance, the current would be same. Yes or no? Current would be same. Makes sense because they are in series. So can I say that? Can I say that? Let's try to solve. R1, we know that this R1 and this is same. Okay, R1 and R4 is same. So R1 is what? L1 by K1A is same. And R2 is equal to L2 by K2A. Yes, right? Which is 5L1 by 5K2 into A, right? So 5 will get cancelled. So sorry, K1. So ultimately R1 is equal to R2. Yes or no? Tell me, yes or no? Means all the 4 resistance are actually same. Agree? So this R1 and this length and this length is same, right? This and this are same. So can I say if this and this are same, right? I can use this equation now. IT is equal to first one, this one, 25 minus 20 by R1. Makes sense? Tell me, makes sense? Yes or no? And this is equal to this current, right? Which is T4 minus of minus 20 by R2. Anyone have any issue in this? Tell me, anyone have any issue in this? Which is equal to T4 plus 20 by R1 because R2 is equal to R1. Okay. So if you equate it, you can get T4 is equal to minus 15. Yes or no? Tell me. Minus 15 degrees centigrade. Yes or no? Anyone have any issues in this? Tell me, anyone have any issue in this? So T4 you got? Now, this too is not given. Neither R nor L is not given, right? This is LL. Okay, but we don't need it because we can say 20 minus T3 minus T4 by R. Yes, R will get cancelled. T4 we calculated. So T3, 2T3 is equal to 20 minus plus T4, which is equal to minus 5, sorry, plus 5. So T3 is equal to 2.5 degree centigrade. Anyone have any issue in this? Anyone have any issue in this? Can you hear me clearly? Yes? Okay, very good. Okay, so that is the concept. That is the concept of series. I hope all have understood the concept of series, right? So let's try to understand the concept of parallel. Okay, so parallel. Now we know that in parallel, right, we studied that the voltage difference should be same. Yes or no? Tell me, right? Yes or no? So in this case, right, when you talk about heat current, okay, when you talk about heat current, we should have temperature difference should be same. Temperature difference should be same, right? Yes or no? Got it? Tell me, got it? Now, think about it. Suppose I'm having this connection, right? Suppose I'm having something like this. Okay. So we have these two rods, right? There are two rods. So it is K1, A1, L1, K2, A2, L2. Got it? Now this is a temperature T1 and this is a temperature T2. So what can I say? Right? Think about it. What can I say? Can I say that, okay, whatever current is entering in this, whatever heat current is entering in this, right, and coming out of this is actually divided into two portions. Yes or no? Suppose this is IT, right? So can I say that, okay, this IT is divided into two parts, which is I1 plus I2? Yes or no? Tell me. Yes or no? I1 plus I2. Makes sense? Tell me. Makes sense? Yes or no? Tell me. Yes or no? Because this total heat can be divided into two rods, which is I1 and I2. Yes, agree? Now, IT, when you talk about IT is between T1 and T2. So I can write like this, T1 minus T2 divided by R equivalent, right, is equal to I1 is what? I1 is okay. I1 is T1 minus T2 by R1 plus what is I2? I2 is again T1 minus T2 by R2. Yes or no? Tell me. Yes or no? Easy, right? So I can cancel this T1 minus T2 now. So I'll get 1 by R equivalent is equal to 1 by R1 plus 1 by R2, right? So this is same as current. Yes or no? Same as current, electric current. Anyone have any issue in this? Tell me, anyone have any issue in this? Okay, clear, right? Clear? Okay, so I'll send some questions on WhatsApp, okay, from HCOM itself. I would request you to guys solve some HCOM problems. Okay, next class, as I told you, we'll be having 2 classes. One class will be doubt solving of fluids, and second class TPP fluids, and second class would be the problem solving of this chapter. We will be solving lots of problems on this topic, because this topic is very important. Okay, right? I hope all of you understood today's class. Tell me, guys. I hope all of you understood today's class. Everything you understood, raise your hand. Okay. Okay, don't leave. Don't leave. You have to tell your attendance. Okay, so you guys stay here for 1 minute, right?